In this particular unit, the topic of solution is subdivided into three: solute, solvent, and solution. The topic of this particular video will be based on solvent. A very popular solvent is water. Water is known as the common solvent. We utilize this to dissolve many substances. Now, water has a very important components of our life. I mean, it's all around us, right? And it allows temperature of the earth to cool, and it moderates that temperature of the earth. It also provides transportation through cargo ships, boats. It also hydrates us, and lastly, it can provide nutrients for the plants and help them grow. I mean, there are so many ways how water could affect human life. In chemistry, water is a big component of a solvent. What that means is that the water is a good substance in which the solute or any type of salt or solid can dissolve well to form into a solution. So, hence the name of this title, Water, the Common Solvent. Let's dive in a little more about this dissolving action. Okay, now the characteristic of the water allows us to really see how substance can dissolve. Let's look at the characteristics. The water in itself are bent in shape. So here's my oxygen, and here's my two hydrogen attached to the oxygen via covalent bonding, and they have this bent geometric structure. Then you will probably notice this squiggly line that's partial negative, and this is a partial positive on the hydrogen. So hydrogen has partially positive charge, and the negative partially charged is on the oxygen. Having this one side being more negative and the other side being more positive gives this entire molecule what we call a polarity, or this is considered to be a polar molecule. Having this partiality or polarity gives them, if you will, the power to dissolve solutes. Let's show you in an illustration. So in here, this is a sodium chloride cube. So here, the negative portion is the chlorine and the positive is sodium, Na. Okay. So here's my chlorine and here's my Na. And you can see this water molecule all around it, and they're starting to come towards close to the salt. This salt over here in the negative portion, you can see the hydrogen kind of orienting itself that it comes closer to the negative. Why? Because the partially charged positive are attracted to a very highly charged chlorine molecule. So it does come in and it starts to surround the chlorine. So you could see sodium being surrounded by the water molecule. In particularly, the hydrogen is sort of attaching to itself. And this surrounding occurs not only in chlorine, but also sodium as well. So sodium is the positive charged one. And you can see the partially negative charged oxygen comes closer and closer, surrounding it itself. And also this is known as hydration. It's literally hydrating around the anion and the cation and pulling these apart, allowing this pulling action, okay, this pulling of the positive and negatives to separate from each other. It allows the sodium chloride to dissolve, and you can't see them in water because they're being hydrated by water, surrounded by water. So let's do another GIF image. This one shows an movements here. So you could see water coming in, pulling off the positive and the negatives, so that this cube of salt will start to dissolve. Until all of them dissolve, you will see a clear liquid in the end. So water is a great solvent for hydration. If I were to put that sodium chloride, that's solid right here, in water, it will split off into sodium plus and Cl minus. And you see the sign AQ. AQ means aqueous, and it means that it is dissolved in water, that they are hydrated by water. Sodium still in there, chlorine is still in there. It's just that because they're dissolved by water, we see this equation as AQ because it means that it's surrounded by water. Some textbook will show this as without being separated by CNA, Cl, and AQ. And this is basically the same as written in this format.